Well, here's a couple of questions where understanding of moles and how many things are in solution is important. So the first question says, how many moles of ions will be present in this volume and this concentration of sodium phosphate? So I know I have these formulas. C equals N over V and N is equal to M over capital M. If I have a C and a V, I can figure out N. Let's do that first. So N is equal to C times V, and concentration 0.450 moles per liter times, well, that's in milliliters. I'll fix that, over 3. So it'd be 0.716 liters. Liters cancel. So let's figure out what that is. Grab my calculator. Okay, 0.450 times 0.716. So I get 0.3222 moles of sodium phosphate. Okay, now it's important to write that formula down, because if they said how many moles of sodium phosphate, this is your answer. But if they have a solution, of this stuff, sodium phosphate dissociates according to this. Sodium phosphate, if you dump that in water, it'll dissolve into, or dissociate into sodium ions and phosphate ions. Now, to balance this, there'd be 3 sodiums, so I need 3 there, 1 there, 1 there. So for every 1 mole of sodium phosphate, I have 3 moles of sodium ions. So all I need to do is take this number, times it by 3. So I could write it this way, 0.3222 moles of sodium phosphate times 1 mole of sodium phosphate gives us 3 moles of sodium ions. See where this 1 comes from? Right there. And this 3 comes from right there. Okay, so let's take our number that we had there and times it by 3.966. So the moles of sodium ions are equal to 0.9666 moles. I should have put moles up here. Okay, so now, doing the sig fig thing, it looks like I have 3 sig figs here, 3 sig figs there. I didn't use any other number. These numbers here are exact numbers, so they don't figure in on the sig fig. So I should have 3 sig figs. So I'd call this 0.967 moles. And it's interesting because in the question, it looks like they didn't round to the correct number sig figs. Anyway, 967. Question. If you mix 20 mils of a 3 molar sugar solution with 30 mils of a 4.18 molar sugar solution, you'll end up with sugar solution of what? So what you have to do with this one is you need to take these and figure out moles. Take these, figure out moles, and then add those 2 together. That'll give you the total number of moles in a solution, and then you divide it by the total volume of the solution, which would be 20 plus 30 or 50. So let's do it. So concentration is equal to moles over volume. So moles is equal to C times V. So for the first solution, the concentration is 3 moles per liter times the volume, liters. 0.0200 liters. There's a decimal there. Liters cancel. So 3 times 2 will be 0.0600 moles. So that's how many moles are contributed from the first solution. Second solution, same formula, C times V. So the C is 4.18 moles per liter times 0.030 liters. Liters cancel. So I can't do that in my head. 4.18 times 0.03. So that gives me 1254 with a decimal at the front. And that's moles. Okay, so my total number of moles is going to be equal to 0.06 plus 0.1254. Okay, 0.06 plus 0.1254. So this would be 0.1854 moles. That's the total moles. So to get my concentration, I figure out moles over volume. Moles 0.1854 moles divided by the total volume, which is 20 and 30, that'd be 50 milliliters. But to convert that, whoops, I need a 5 in there. It'd be 0.05 liters. So 0.05 liters. Okay, so 0.1854 divided by 0.05. So the concentration will be 3.708 moles per liter. Sig figs, 3 everywhere. So I'd call this one 3.71 moles per liter. Right there. Okay, hopefully that helps you with those 2 questions. Just getting that understanding of moles.